Hi guys, today we're going to solve another 3 problems for the first law of thermodynamics. So this will be the fourth part of our discussion about the first law of thermodynamics. So we will be solving these 3 problems kung saan we will be applying yung mga natutunan natin in our lecture videos about the first law of thermodynamics. Okay? So these 3 problems that we are going to be solving today will be very useful sa inyong pag-aaral in the first law of thermodynamics. So, meron tayong kinuha sa iba't ibang reference books na meron tayo. Okay, so hindi na natin patatagalin pa. Let us dive now to our lecture video. Alright, so let us start with our first problem. The input work to a paddle wheel used to steer a bowl of water is 6,000 kJ. So, illustrate muna natin yung ating condition. So, let us say this is our bowl of water. Okay? So, there is a water inside. Let's say this is it. And then a paddle wheel is used to steer it. So, let's say this is our paddle wheel. And the input work to a paddle wheel used to steer a bowl of water is equal to 6,000 kJ. So, we have a work, let's say this is W. Our work is equal to 6,000 kJ. Okay? Now, at the same time, 2,400 kJ of heat is rejected by the bowl of water. Okay, so there is heat rejected here, which is equal to 2,400 kJ. Okay, so we need to determine the internal energy change in kilojoule of the system. Okay, so our required is to find out what is the change in internal energy in terms of kilojoule. Okay, so let us have our solution here. And of course, we're going to apply the first law of thermodynamics, which states that energy cannot be created or destroyed, but can be transferred in another forms. Okay, so we learned from our previous video that delta U is equal to Q plus W. So this is basically what we're going to use in dealing with the first law of thermodynamics. Okay, and we are looking for delta U. Okay, so our Q, which is the heat, okay, involved in our situation here. Okay, so the heat is actually released from our system, right? Because the heat is being rejected by the bowl of water. So there is heat coming out, so therefore our heat will be in negative because it is leaving our system. So we have negative 2,400 kJ. Then how about work? Work is added to the system. The work is done by the surrounding and received by our system, so therefore this is positive. So we have plus 6,000 kJ. Okay, so our delta U is equal to negative 2,400 plus 6,000 kJ will be equal to positive 3,600 kJ. Okay, so this will be our final answer for this problem. And as you can see, we have a positive change in our internal energy. Therefore, there is an increase in internal energy when we add 6,000 kilojoules of work and release 2,400 kilojoules of heat. Okay? So, mag-i-increase yung ating internal energy. Okay? So, let us go to the next problem. Suppose that 190 kJ of heat is added to a closed system, executing a process from state 1 to state 2 in which the internal energy is increased by 106 kJ. To restore the closed system to its initial state, meaning from state 2 to state 1, 100 kJ of work is done on the system. So what is heat 2? Okay, the heat added or rejected in kilojoules. Okay, so let us illustrate our conditions here. So we have two states. Now we have state 1 and then we have state 2. Okay, so let's say this is our state 1 and this is state 2. Alright, so 190 kilojoules of heat is added to a closed system, executing a process from state 1 to state 2. So in changing from state 1 to state 2, heat is added in here, which is 190 kilojoule. Okay, heat is added from state 1 to state 2. And then because of that, our internal energy was increased by 106 kilojoules. So we have delta U, which is equal to 106 kilojoule. Okay, so this is what happened when we change from state 1 to state 2. Now, we want to restore the closed system to its initial state. So, babalik tayo sa ating initial state, no? From state 2 going back to state 1. Okay, so kailangan na maging condition ng ating system is bumalik sa state 1. So, dito, kung maaalala ninyo, nag-increase ang ating internal energy. So, therefore, para bumalik tayo sa initial condition natin, we need our internal energy to reduce by 106 kilojoule. Okay, so it means our delta U here shall be reduced by 106 kilojoule. Okay, so bumaba yung ating internal energy. And to do that, we introduce work to our system. Okay, so work is done on the system. So therefore, our system receive work from the surrounding. Okay, so if it receive work from the surrounding, therefore it should be positive. And this is equal to 100 kilojoule. Okay, so ang hinahanap dito is what is our Q. So basically, hindi na importante itong heat at the beginning because ang hinahanap lang naman sa atin is how are we going to go back to our initial condition. Okay, so that means we have to use our records here or our data here going back from state 2 to state 1. Okay, so applying again the first law of thermodynamics, energy cannot be created nor destroyed but can be transferred from one form to another. And we will be using again this equation. Delta U is equal to Q plus W. Okay, so we want to go back from state 2 to state 1. So therefore, our internal energy should be reduced by 106 kilojoules. So we have negative 106 kilojoule is equal to, we don't know the value of our heat. Ito yung ating hinahanap. And then, the work is received by the system coming from surroundings. So therefore, it should be positive. So we have plus 100 kilojoule. Okay? So therefore, our Q will be equal to negative 106 kilojoule minus 100 kilojoule. So our Q will be equal to negative 206 kilojoule. So this will be our final answer here on this question. And as you can see, our sign is negative because heat is released from the system to the surrounding. Okay, so to go back from state 2 to state 1 and adding 100 kilojoules of work, you will be releasing 206 kilojoules of heat in order to go back to our initial condition. Okay, so our last problem will be this one. And this is problem 2.37 from Fundamentals of Engineering Thermodynamics by Moran and Shapiro, 5th edition. Okay, so let me read our problem. As shown in figure P 2.37, 5 kg of steam contained within a piston cylinder assembly undergoes an expansion from state 1, where the specific internal energy is U1, which is equal to 2709.9 kilojoules per kilogram, to state 2, where our specific internal energy is equal to 2659.6 kilojoules per kilogram. So take note, ang given sa atin dito is specific internal energy. That is why it is divided by its weight. Okay? During the process, there is heat transfer to the system with magnitude of 80 kilojoules. Okay? So during this process, there is heat transfer to the system. So therefore, our system is receiving heat. So as you can see here, it is positive because it is receiving heat from the surrounding. Okay? Now, the paddle wheel transfers energy to the steam by work in the amount of 18.5 kilojoule. Okay, so we have a paddle wheel here and the work being done is equal to 18.5 kilojoule. So, in the illustration, makita ninyo, our sign is negative. So, as I said sa ating initial video ng ating series for the first law of thermodynamics, the sign will be depending on your perception, no? Kung saan mo siya tinitignan. That is why different books are using negative and positive sign in work. Okay, but I already explained this in our first video. Kung medyo nalilito kayo, panoorin nyo lang uli yung first video natin in order to understand why we have positive and negative here. Because even though this is positive here, I will show you that in my solution, I will not be using this negative sign. Okay, para mas makita ninyo how are we going to apply yung mga natutunan natin last time. So, the point here now is that there is a work, okay, produced by the paddle wheel which is equal to 18.5 kilojoule. There is no significant change in the kinetic or potential energy of the steam. Determine the energy transfer by work from the steam to the piston during the process in kilojoules. So, ito yung ating requirement. What is the work done by the piston or done on the piston? Okay, so yan ang ating i-determine. Okay, so we will be using again yung ating equation for the first law of thermodynamics. We have delta U is equal to Q plus W. Okay, so our kinetic and potential energy as mentioned here, there is no significant change. Okay, so therefore our delta E or delta KE, our kinetic energy, plus delta PE, which is our potential energy, is equal to 0. Okay, so this is 0. Wala tayong change sa ating kinetic and potential energy. Now, looking back dito sa ating illustration, as you can see, specific internal energy ang given sa atin. Okay, so if we want to get our delta U, which is the change in internal energy, we have to multiply this to our weight, okay, or our mass. So therefore, our delta U will be equal to mass times the specific internal energy 2 minus mass times the specific energy 1, and this is equal to Q plus W. Okay, so our mass is equal to 5 kilogram here, so we can factor out itong mass. So we have M times U2 minus U1 is equal to Q plus W. Okay, so take note, even looking on this illustration, you can see that there are two works involved. We have work coming from the paddle wheel and the work from the piston or to the piston. Okay, we need to determine kung ano ba yung nangyayari sa ating system. So therefore, our network, okay, so let me write here our network, work net, is equal to, let us see first itong ating work from the paddle wheel. Okay, so should I use positive or negative sign sa ating work coming from the paddle wheel? So let us see our question again. A paddle wheel transfers energy to the system. So therefore, the energy or the work is coming from the surrounding to the system. So our system is receiving work. Okay, ang system natin dito is itong ating steam. Okay, so our steam or our system is receiving work from the paddle wheel. So sabi ko nga ng mga previous video natin, if it is receiving work, it should be positive sign, depending kung ano yung equation na ginagamit mo. Now, in the illustration, they use negative sign, but in my solution, I will use positive sign because it is our system is receiving work from the surrounding, which is the paddle wheel. So I will use positive here. So I have positive work from the paddle wheel. How about from the piston? Okay. Well, if we're going to look at our question, it is actually clearly mentioned here that the energy transfer in a form of work is from the steam to the piston. Therefore, the flow of energy is from the system to the surrounding. So, in this case, our steam is actually expanding. That is causing our piston to move from one point to another. Okay, so therefore, the work will be done by our system. So, I could say that since it is our system or our steam that is producing work to the surrounding, so its sign should be negative. So, we have negative work on the piston. Okay? So, I'm going to substitute this network dito sa ating equation dito because this W here represents all the work involved sa ating system. And on this case, we have two types of work, the work from the paddle wheel and the work from the piston. So, let me substitute that. I will have M times U2 minus U1 is equal to Q plus work from the paddle wheel minus work from the piston. Okay, so our requirement is to find this WP, the work from the piston. Okay, so I'm going to transpose WP to the right, and this one I'm going to transpose to. So I'm going to transpose this negative WP to the left, and this M times U2 minus 1 will be transposed to the right side of the equation. So I will have work on the piston will be equal to Q plus work from the paddle wheel minus mass times U2 minus U1. Okay? So now let us substitute our values. So we have work on the piston is equal to Q. Our Q is equal to 80 kilojoules. So we have 80 kilojoules plus our work from the paddle wheel, which is equal to 18.5 kilojoules. So we have here 18.5 kilojoules minus our mass. Okay, so our mass is equal to 5 kilogram of steam. So I will have here 5 kilogram times our specific internal energy 2, which is 2659.6. Okay, so 2659.6 kilojoules per kilogram minus our specific internal energy 1, which is 2709.9. So 2709.9 kilojoules per kilogram. Okay, so our units here will be cancelled out, itong kilograms natin. So ang may iwan here is only in kilojoules. Okay, so let us solve for our work in our piston. Okay, so let us use our calculator. Okay, so we have 80 plus 18.5, which is equal to 98.5 minus 5. Okay, 5 times 2659.6 minus 2709.9, and our answer is 350. So we have positive 350 kilojoule. Alright, so ito yung ating final answer here. Okay, now the question is, bakit positive yung sagot natin dito? Because as you can see here, sabi nga natin, positive should mean that we are receiving work from the surrounding to our system, and negative is if we are releasing our work from the system to the surrounding. Okay, because we already set this as negative dito sa ating equation, because we already considered yung direction ng ating work. Okay, so this is understood as leaving our system because we already wrote it here. Okay, we have negative WP here and here. Okay, so therefore we already know that our WP is leaving our system. Now, kung gagamitin ninyo is yung other equation and you put this as plus, makikita ninyo ang sagot ninyo dito will be negative, indicating that the direction is going out of our system. Okay, so yan yung pinagkaiba niya. Yan yung sinasabi ko noong nakaraan, that it will depend on how you use the equation, no? Ang mahalaga rito, you know what is going on and you know how to use the equation na pinili ninyong gamitin. Okay, so in order to be clear, I would write here what actually happened. Okay? So it means here that energy is transferred from the system. So this 350 kilojoule is the energy transferred from the steam, which is our system, to the piston. As the steam expands during the process. Alright, so we already solved 3 problems dito sa ating lecture video for today, and I hope it helped you sa inyong pag-aaral for the first law of thermodynamics. And actually, there is still a lot of things that we need to discuss for the first law of thermodynamics. And we will be moving to the next stage of our discussion on this topic in our succeeding video. Okay, so this is all for now. Thank you very much and have a nice day. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa engineers.org.